In early 2017, on a small green island in the middle of the Indian Ocean, a team of scientists crouched down in the rainforest and quietly opened a row of mesh containers. Whatever came out of them was so small that if you had been standing 3 feet away, you would have seen nothing at all. No swarm, no cloud, no movement you could name. Just a faint shimmer in the leaf litter, and then nothing. Inside those containers were tiny wasps, each one roughly the size of a grain of rice, bred in a laboratory and flown here for a single purpose. The people letting them go were not starting something gentle. They were releasing them by the million into the heart of one of the most destructive invasions the natural world has ever recorded. An invasion that had already killed tens of millions of animals and was quietly hollowing out an entire forest from the soil up. And here is the part that took me a long time to get my head around. These wasps would go on to break the back of that invasion. They would do what aerial poison drops, millions of dollars, and years of effort had never managed to do permanently. They would hand the island back to the animal that built it, and they would do all of it without ever killing a single one of the creatures they had been sent to stop. On paper, the whole idea sounds like madness. The island was already in this mess because foreign species had been let loose on it. So the proposed fix was to deliberately release another foreign species, one almost too small to see, and trust it not to make everything worse. Every instinct says you cannot answer an ecological catastrophe with an insect you need a hand lens to find. You certainly cannot do it by adding yet another stranger to an island that strangers had already wrecked. That instinct turned out to be wrong. Not slightly wrong, completely, spectacularly wrong, because the scientists releasing these wasps had figured out something that the people fighting the invasion with poison had missed for years. They had stopped trying to fight the visible enemy. They had gone looking for the thing feeding it. What that one decision set off across the island is something that conservation biologists still hold up as one of the cleanest examples of its kind anywhere on Earth. A collapse on one side, a return on the other, and a forest that had been falling silent for 2 decades, beginning almost overnight to fill back up. I'm Lawson Gray, and this is the story of how an island nearly lost the animal that runs it, and how the rescue came not from force, but from something the size of a grain of rice that knew exactly which thread to pull. To understand why that worked, you need 3 things. You need to understand what this island's true owner actually is, because it isn't what the tourists come to photograph. You need to understand the invisible war that had been bleeding it dry. And you need to understand the elegant, almost ruthless logic of how a microscopic wasp ended it. But it starts with the animal, and the animal is a crab. The place is officially called Christmas Island, an Australian territory about 350 kilometers south of Java, a single forested mountaintop pushed up out of the Indian Ocean. But almost nobody who knows it calls it that first. They call it the Island of the Red Crabs because at its peak, this island was home to 40 to 50 million of them. Now, when most people hear land crab, they picture something small and skittering, a curiosity at the edge of a beach. The Christmas Island red crab is nothing like that. It is a bright crimson, fist-sized animal that lives its entire adult life on the forest floor, often a long way from the sea. And there are so many of them that the ground itself seems to move. And here is the thing you have to understand, because the entire story turns on it. The red crab is not just a resident of this forest, it is the engineer of it. It is the single most important animal on the island, and it is important not because of how it looks, but because of what it does. A red crab is, in effect, a gardener that never stops working. They are the dominant consumers of the forest floor, and they devour the fallen leaf litter almost as fast as it lands, shredding it, eating it, and recycling those nutrients straight back into the soil. They eat seeds and seedlings by the millions, and in doing so, they decide which plants get to grow and which ones don't, sculpting the entire understory of the forest. They dig deep burrows that aerate the ground and let water and air down into the roots. Take all of that together, and the red crab stops being a crab in a forest. It becomes the thing that shapes the forest. Pull it out, and you don't just lose a charismatic animal. You switch off a process that has been running for longer than there have been people to watch it. And once a year, that process becomes one of the most astonishing spectacles on the planet. When the wet season rains arrive, tens of millions of red crabs leave the forest all at once and march to the sea to breed, a moving red tide that flows over roads, up walls, across whole districts of the island. The authorities close highways and build crab bridges and tunnels just to let them pass. It is the kind of thing people fly across the world to witness once in their lives. It is the island's beating heart made visible. That heart was about to be attacked by something that weighed almost nothing. Sometime in the first half of the 20th century, almost certainly by accident and almost certainly aboard a ship, a new insect arrived on Christmas Island. It was the yellow, crazy ant. The name comes from the frantic, erratic way it moves when disturbed, but there is nothing frantic about what it did to this island. For decades it was just present, a minor passenger, kept in check by its own modest numbers. And then it found a partner, and everything changed. That partner was another introduced species, a tiny sap-sucking insect called the yellow lac scale. The scale insect spends its life clamped onto the bark and stems of the island's trees, drinking the sugary sap and excreting the excess as a sweet liquid called honeydew. To the yellow crazy ant, that honeydew is rocket fuel. The ants began farming the scale insects like herds of livestock, guarding them, tending them, harvesting their sugar. And that endless, effortless flood of energy let it form super colonies. This is the detail that matters. A normal ant colony has one queen and competes with the colony next door. A super colony has no borders and no rivalry. Hundreds of queens, billions of workers, all cooperating across kilometers of forest as a single sprawling entity. On Christmas Island, fueled by all that scale insect sugar, yellow crazy ant densities reached levels that almost don't sound real, with thousands upon thousands of ants per square meter, blanketing the forest floor in a living, churning carpet. And it fed on itself. The more scale insects the ants protected, the more honeydew they harvested. The more honeydew they harvested, the more workers and queens they could support. And the more workers they had, the more scale insects they could farm and defend from anything that might have eaten them. Round and round, tighter and tighter, a loop that had no natural break on this island because none of the players had ever lived here together before. The super colonies didn't have to fight each other for territory the way ordinary ants do, so they simply spread, budding off new nests and merging into a single front that crept outward through the forest, kilometer by kilometer, until it covered something on the order of a quarter of the island's rainforest. And straight into that carpet walked the red crabs. The ants don't bite or sting in the way you'd expect. They do something worse. When a red crab moves through a super colony, the ants swarm it and spray formic acid into its eyes and into the soft joints of its legs. The acid blinds the crab and breaks down its body. Disoriented, unable to defend itself, the crab is overwhelmed where it stands, and the colony consumes it. The super colony zones became, in the plainest possible language, killing fields. Crabs that wandered in did not wander out. The toll was staggering. Across the worst-hit forest, the super colonies are estimated to have killed somewhere between 10 and 15 million red crabs, close to a third of the entire population, and they had taken over many thousands of hectares of forest in the process. And the annual migration, that great red tide, was being funneled straight through ground where the ants were waiting. But the death of the crabs was only the first wound. Because remember what the crab actually is. When you remove the animal that eats the leaf litter stops disappearing and begins piling up in thick drifts. When you remove the animal that eats the seedlings explode unchecked, and the open forest floor closes into a tangled understory. The whole character of the rainforest started to change in the super colony zones, shifting into something the island had never been. And other invaders that the crabs had always held in check, like the giant African land snail, suddenly found the door wide open. And the damage wasn't only on the ground. All those scale insects, multiplying under the ants' protection, were drinking sap from the trees and pouring out honeydew faster than anything could use it. That sticky residue coated the leaves, and a black fungus called sooty mold took hold and grew over it, smothering the canopy in a dark film that blocked out the very sunlight the trees needed. In the worst stands, whole crowns began to thin and die back from above. The forest was being attacked from the top and the bottom at the same time, starved of light in the canopy, stripped of its engineer on the floor. And the red crab wasn't the only giant the ants were hitting. Christmas Island is also home to the robber crab, the largest land-living invertebrate on Earth, a coconut-cracking monster that can outlive a human being. Even that animal, armored and enormous, was not safe from a super colony that could swarm it in numbers no single creature can fight. When an invasion is killing the biggest invertebrate on the planet as casually as it kills the small ones, you are no longer looking at a pest. You are looking at something rewriting the rules of an entire island. This is what an invisible war looks like. No single dramatic event, just a slow, grinding collapse, 1 square meter at a time as the island's engineer was erased and the forest quietly drifted towards something else. For years, the response to all this was the obvious one. Force, fight the visible enemy. Land managers carried out large-scale aerial baiting programs, dropping ant poison across the worst super colonies. And it worked in the way that poison works. It knocked the ant numbers down hard and bought the crabs some breathing room. But it was never an ending. Baiting is expensive. It has to be repeated. It carries its own risks for other wildlife. And the moment the pressure comes off, the super colonies have every opportunity to rebuild. You cannot poison a problem like this forever. You are not solving it. You are just paying, again and again, to hold it at bay. And the scale of that effort was enormous. Helicopters flew grid patterns over the canopy, broadcasting tons of insecticide bait across thousands of hectares of forest in campaigns that ran across the early 2000s and beyond. Each one would crash the super colonies in the treated zones, and for a while the forest there would breathe again. But the poison they leaned on was a broad-spectrum insecticide, the kind that doesn't only kill the target. It was a blunt instrument used as carefully as anyone could manage, on an island full of species found nowhere else, and everybody involved knew it could not be the permanent answer. Every drop was a holding action, a way to stop the bleeding while somebody, somewhere, found a real cure. The trouble was that nobody had one. So a team of researchers at La Trobe University working with Parks Australia asked a different question, not, how do we kill more ants? They asked, where does the ant get its power in the first place? And the answer, as we've seen, was the honeydew. The whole monstrous super colony system was being bankrolled by the yellow lac-scale insect. Cut off that sugar supply, the reasoning went, and the super colonies should starve back down to ordinary survivable numbers all on their own. You wouldn't need to kill the ants at all. You would just need to take away their funding. The question was how. And for that, the team did what good ecologists do. They went back to where the scale insect originally came from, its native range in Southeast Asia, and they asked why it wasn't a runaway plague there. The answer was that, back home, the scale insect has natural enemies that keep it in check. Predators and parasites that have evolved alongside it for millions of years. One of them was a tiny parasitoid wasp from Malaysia, roughly 2 millimeters long, a specialist that does one thing. It hunts the yellow lac scale. The way it works is quietly merciless. The female wasp seeks out the scale insects, lays her eggs inside them. Her larvae devour the scale from the inside out. She kills more still simply by feeding on them directly. Where this wasp is present in good numbers, the scale insect can never build the explosive populations it had reached on Christmas Island. And without those populations, there is no honeydew flood. And without the honeydew flood, there is no fuel for a super colony. Here is the elegance of it, and the twist the whole plan was built on. The headlines call it the ant killer, but the wasp has no interest in ants whatsoever. It will never touch one. It was sent to attack the ants' hidden food supply, the sugar factory propping the whole invasion up. They weren't going to fight the army. They were going to cut its supply lines and let the army collapse on its own. But you don't just dump a foreign insect onto a fragile island and hope. That is exactly the kind of recklessness that created this disaster in the first place. And the people behind this knew the warning by heart because the most infamous example in the world had happened in their own country. Decades earlier, Australia had imported the cane toad to control beetles in its sugarcane fields. The toad ignored the beetles, bred without limit, and it became a poisonous plague that is still killing native wildlife today. That is the nightmare that hangs over every attempt to fight one introduced species with another. Get it even slightly wrong, and you create a second problem you can never take back. So before a single wasp was released, the team did the opposite of reckless. They spent years on painstaking host specificity testing, rearing the wasp in secure quarantine. They confirmed that it attacked the target scale insect, and only the target scale insect. That it would not turn on the island's native species once its job was done. They had to be able to prove that this 2mm specialist was so narrowly built around hunting one kind of scale insect that it could be trusted loose in one of the most delicate ecosystems on Earth. More than a decade of research went into being that certain. Only when the evidence was airtight did the approval finally come. And in 2017, they carried the containers out into the forest, opened them, and let the wasps go. And then the thing that no amount of poison had ever achieved began to happen on its own. The wasp did exactly what it was supposed to do, and it did it for free. It established, it bred, it spread out from the release sites under its own power, hunting the scale insects wherever it found them, generation after generation, with no further help and no recurring cost. There were no more aircraft, no more bait, no more bills. Once it was out there, the wasp simply went to work and never stopped. And as the scale insect populations crashed, the honeydew dried up. And as the honeydew dried up, the rocket fuel was cut off. In the release areas, scale numbers fell away sharply, and the crazy ant supercolonies, those churning carpets that had blanketed the forest floor, began to thin and break apart and fall back to densities the crabs could simply walk through and survive. After a war that had ground on for 2 decades, the collapse was startlingly fast. In places it folded within a single season. That is the grain of truth inside that almost unbelievable headline. The change, when it came, really was close to instant, not because the wasp was a weapon, but because the moment you stop feeding a supercolony, it has no way to hold itself together. And into the ground the ants had abandoned, the crabs came back. And this is the point I keep circling back to. What happened here was not really the killing of an invader. It was the repair of a broken food web. The removal of a single artificial subsidy that had let one species spiral out of all proportion. Take the subsidy away, and the system rebalanced itself. When the crabs returned to that reclaimed forest, they didn't just survive there, they went back to work. The leaf litter started disappearing again. The runaway seedlings started being grazed back down. The burrows reopened. The engineer was back at its station, and the forest's oldest process, the one the ants had switched off square meter by square meter, quietly switched back on. The work done by the team at La Trobe University and Parks Australia, it's now cited as one of the most successful self-sustaining biological control programs against an invasive ant anywhere in the world. Not a holding action, a genuine lasting turn. But the part that stays with me isn't in any of the data, it's the migration. Picture what was nearly lost. Every year when the rains come, this island performs one of the last great mass movements of animals left on the planet. A living red tide of tens of millions of crabs pouring out of the forest and down to the sea, so vast that roads close to let it pass. For years, that tide had been marching straight into ground where the ants were waiting, thinning a little more with every season, a spectacle slowly being eaten alive at its edges. The thing that turned it back was an insect 2 millimeters long that most people will never see and could never name. The smallest creature in the entire story turned out to be the one holding the whole island up, and that's the lesson I can't shake. We caused all of this. We carried the ants here, and we carried the scale insect that armed them. And when we finally fixed it, the fix didn't come from more force or a bigger poison. It came from being humble enough to stop fighting the obvious enemy. Go and ask why this insect was harmless in its own homeland, and pull the one thread that held the whole thing together. We didn't outmuscle the super colony. We just stopped feeding it. Returned the natural check that should have been there all along. We just got out of the way while the crabs took their island back. If you found this as remarkable as I do, let me know in the comments. And tell me whether you think we should be trusting careful, tested biological control like this in more places, or whether the risk of releasing one more species is a line we shouldn't cross. If it changed the way you think about what's really running a forest, share it with someone who'd appreciate it. And subscribe, because there are more of these comeback stories than you'd ever guess. I'm Lawson Gray. Thanks for watching.